Pollution and environmental damage have been big problems of which humanity is mostly responsible for. And regarding the sea, definitely the biggest issue is what is known as the black tears of the sea.
During World War II, more than 3,300 military ships and embarkations were sunk. All of these ships required of crew to function and operate correctly. This means that when those boats were sunk, the oil they used stored and used as fuel were lost in the depths of the ocean, causing pollution.
A remarkable example of this event is the one that happened with the German ship the Franklin. These ships were used like a floating gas station that supplied fuel to the naval fleet of Germany during the conflict on the Baltic Sea. This ship stored more than 10,000 tons of crude oil that were spilled all over the Pacific Ocean when the Russians sunk it with a torpedo.
The large amount of oil in the area are obviously a great threat to the environment. In fact, in the surroundings of the sunken ship, all forms of life have disappeared entirely.
But that's not it. A large amount of fuel is still inside the tanks, unreleased. And when said tanks are corroded and collapse, the large amount of contaminants inside may release havoc upon the environment. And that will happen soon, since 1 millimeter of steel is corroded per decade. That might not seem as much, but since the event have passed 76 years, we are running out of time.
Nanotechnology is a very powerful science that offers a very promising way to solve the black tears of the sea. However, the very expensive process of manufacturing of the nanoparticles required make us believe that there might exist better options with cheaper and more effective processes like the biotechnology and the use of genetically modified organisms.
As many may know, the separation process of water and oil is quite hard and time-consuming and expensive. It is estimated that to recover all the crude will require a total investment of $8 to $20 million. Apart from the expensive procedure, one of the challenges of the environmental remediation is to identify the contaminants and have them removed, and if it's aimed to dissolve the said contaminants, it's to identify and remove only the contaminants. Two solutions, multiple innovative methods have risen to help remediation of polluted areas like Baltic Sea, which is where the black tears of the sea are.
One of them is nanotechnology. Nanotechnology for environmental remediation proposes the use of particles or materials that are produced at a nanoscale. This means that these materials are more than 25,000 times smaller than an inch. Not small. And the particularity of these materials is that scientists can design them with specific reactivity. This means that when they are exposed to the contaminants, they react only and specifically to the contaminants they were designed to react to, and only those contaminants. This surely sounds like a very promising way to solve this problem. Or does it? The main flaw of nanotechnology is the manufacturing process of the nanoparticles, which is described as quote-unquote hazardous and highly expensive. To put an example, 1 single milligram of gold nanoparticles is worth $80. 1 milligram. That puts the whole gram in $80,000. 1 gram. When pure and raw gold is worth only $50.
You can imagine that the manufacturing process of large scales like that would be needed to be used in affected areas by black tears of the sea is best described as economically unaffordable.
This, of course, is a problem, but there are many more ways to clean the seas, and a very remarkable one is the use of genetically engineered microorganisms, or GEMs.
The reason why this is so promising is that not so long time ago, on 2016, a scientific Japanese team discovered a bacteria, an amazing bacteria, almost a miracle, named Ionella sacchalensis, capable of digesting some types of plastics and hydrocarbons. This means that it's our first weapon against the problem of black tears of the sea, because with the biotechnology enhancement, it's possible that in the near future we could make a bacteria capable of digesting crude oil and clean the seas.
However, nanotechnology should not be discarded just yet, as the combination of these two powerful techniques is gaining more and more strength. This combination is nanobiotechnology. As discussed earlier, the main issue with the use of nanoparticles is the expensive manufacturing process, and what nanobiotechnology does is replace those conventional methods with the use of genetically modified organisms and gems for the creation of nanoparticles in a more efficient and cheap way. Nanoparticles can now be synthesized in a more green approach by the use of microbes, which is a very efficient way to exploit microorganisms as convenient micro-nano factories.
Bionanotechnology has provided new avenues for the synthesis of nanoparticles and is an eco-friendly, simple, rapid, stable, and cost-effective method. Part of aiding the synthesis of the nanomaterials, gems, like a modified version of Ionella sacchalensis, can help directly by releasing them in the sea.
Our hypothesis was partially correct, as nanotechnology is indeed a very expensive process to solve the black tears of the sea. However, while we were aiming to propose biotechnology and the use of genetically modified organisms as the best way to solve this problem, the rise of nanobiotechnology has proven itself being the best way to solve this problem.
I would like to remember that enhanced bacteria still being alive, capable of reproducing by themselves, which means, at long term, to reduce a lot the prices of production, on contrast with nanotechnology, that you need to a constant massive production in order to be very efficient. So, then biotechnology is not only cheaper, but is very reliable at long term.
Powerful sciences like nanotechnology and biotechnology have taken action into the fields of remediation and bioremediation. A very promising one is nanotechnology and the use of nanoparticles which are manufactured in a specific way so that they can react with specific contaminants. However, the production process of said materials is very expensive and economically impactful, especially if we are talking about massive production. On the other hand, we have biotechnology and the use of genetically engineered microorganisms or gems, which degrade the contaminants in a cheaper way. And in the middle, we have nanobiotechnology, which combines the best features of both sciences into a very affordable and efficient way to treat the black tears of the sea.